Okay, this is a review of the domain problem that comes up with this particular topic, which is advanced combining of functions. So with this particular one, let's take a look at this question. We look at the two functions we're given, and first of all, when you're combining functions, you have to check what the domain of each of the functions are going to be. So f over g, these answers were was done correctly. So this x over 9x plus 63 is really the same thing if you were to distribute this 9 through. Okay, so notice this answer is correct. It's the domain part that's not. So what you have to look at is, you can see from this one here, we can't have a 0 in the denominator. So what we're looking for is what would make x plus 7 equal 0. Subtract 7 from both sides, you get x equals minus 7. You got that part correct. And notice here, that's the correct answer here. Down here, what we're doing is the same thing. What would make the bottom, the denominator, become 0? What would make x equal 0? Well, x equals 0. So that's why this should be, the correct answer here is 0, not 9. Now I'm thinking maybe because you divided, because we're dividing by g, right? So you probably set this up as 1 over x plus 7 divided by 9 over x, which is the same thing as 1 over x plus 7. And then when we divide, do this step, 9x, you flip and multiply, so then you get 1 over x plus 7 times x over 9. And maybe you saw this 9 and thought that that's how you got this, but it's okay to have 9 in the denominator. It just was not okay to have 0. So x cannot be 0 because of this step here. Even though it gets flipped up to the top, because it starts off here in the denominator, we can't have it. Okay, so very close there, just that this 9 needed to be 0. And then this answer would have been correct. Okay, let's come down to the next one. The issue here is kind of similar. Notice it's the bottom part that's not correct. This top part is correct. And actually the way you went about getting this domain is you probably say, well, we can't have a negative inside of a square root. And you're absolutely right. So what you did is you said 5x plus 1 needs to be greater than or equal to 0. And then as you solve this, you subtract 1 from both sides. 5x is greater than or equal to negative 1, divide by 5. So x is greater than or equal to negative 1/5. So that gives us, on a number line, negative 1/5. Negative 1/5 included, and it's greater than, so it goes this way all the way to infinity. And so we get a bracket here, parentheses there. And so that's correct. Notice the second part, really that's the same issue. It's 5x plus 1 is what the problem is. So 5x plus 1 cannot be negative, but there's an additional thing here. Because it's in the denominator, it also cannot be 0. So now it's strictly greater than 0. It doesn't have this equal. Not equal to, okay? And when we do all this solving, we get the same thing. We get that x has to be greater than negative, I almost put that equal there, negative 1/5. So it looks so close to this, except instead of a bracket, it's a parentheses. Okay, goes on forever. So this answer here was very close to that. It should have just been 1/2 minus 1/5 parentheses infinity. Now, where the 0 came from, it could be that you're thinking, oh, we can't have 0 in the denominator. You are correct, but what would cause the 0 in the denominator is a negative 1/5 plugged in for x. That would give us a square root of 0, which is 0. So, and again, when we've got it in the denominator, it just changes the bracket to parentheses. So that's, I noticed some of the questions you were answering, that's kind of what it was. It was whenever the square root is in the denominator, you have to remove the endpoint because it can't be equal to 0. When it's not in the denominator, we can have the bracket, we can have the endpoint included. Okay, and then I think there's one more to go over, and hopefully this will help, because that's what I saw the main problem was the problem of domain. Okay, and here's the same thing. Notice you've got the domain for f over g, perfect, great. Square root is up here. You took 2x plus 3 has to be greater than 0 because it's in a square root, and it can't be equal to 0 because it's in the denominator, right? So you solve this, subtract 3 from both sides. 2x is greater than negative 3, divide by 2. So you got x has to be greater than negative 3/2. And that's how you got this part. Up here, we have the same sort of issue, but it's 2x plus 3 can be greater than or equal to 0 because it's not in the denominator of a fraction. It can be equal to 0. So we go through the whole same process. We get really we get x greater than or equal to negative 3/2. So really it's the same answer, except with this one, we get the bracket. So you see how you are just so close to getting the right answers, but that's what I kind of don't like about this one little thing. Now this, again, yeah, it doesn't go all the way to negative infinity. It really goes here, 3/2 bracket to infinity. But you're just sort of like one part of the domain that you're off on each of these. And I know how it must be frustrating to go through and get, there's a lot of work to put into each of these, getting each of these function parts right. And as I reviewed, just about all of them are correct. One that you did get in incorrect, you corrected pretty well, but it's the domain that's getting that's holding you back. So hopefully this will help you deal with that specific issue of when do we have a bracket, when do we have a parentheses. And again, it's a difference between whether the radical is in the denominator of a fraction or whether it's not. The other issue on this one is, well, sort of the same thing, yeah. This one, yes, this was correct because of the bracket, so you got that. This one should not have had a bracket, and also, again, it's just where it's at the negative 1/5. Let's see, what did we get up here? And this one, I think maybe it was just an oversight, but let me see if this helps. Give me a call come give me a call. Give me a call on Zoom during my office hours or class time in the morning, and we could work side by side with these. You can share your screen with me. We can work them through. So that before you submit them, I can check for the little details to make sure everything's perfect. That way you can get the 3 in a row and keep moving forward on to other things because you're really making great progress. Anyway, thanks.